Hello, so my name is Brandon Kleber, and my presentation is on the topic of crash testing. So, crash test dummies for a long time have been the subject of public service announcements, cartoons, parodies, even the name of a 90s rock band. Real crash test dummies, though, are lifesavers as a huge part of automotive crash tests. Even though cars continue to get a little safer every year, and fatality rates continue to decline, car crashes are still one of the leading causes of death in the US. One of the reasons cars are getting safer is because of these well-established testing programs that I'm going to discuss with you all. In these 10 minutes, I'm going to tell you all about vehicle crash testing, including dummies, crash test programs, ratings, and even possible future improvements. I was amazed to learn about how much thought and preparation goes into making sure that safe cars are on the roads. So I hope you all learn as much as I did by the end of this presentation. To start with, all frontal crash tests in the US are now conducted using the same type of dummy, the Hybrid 3, which was designed by GM in 1977 in order to become the industry standard and guarantee consistent results. The dummy's job is to simulate a human being during a crash, so it is built from materials that mimic the physiology of the human body. For example, it has a spine made from alternating layers of metal discs and rubber pads. The dummies come in different sizes, and they're referred to by percentile and gender. So for example, the 50th percentile male dummy, which is the most commonly used one in crash testing, weighs 170 pounds and is 70 inches tall. The dummies contain three types of instrumentation: accelerometers, load sensors, and motion sensors. There were actually two very famous dummies, Vince and Larry, who were part of a huge safety belt campaign by the US Department of Transportation in the 1980s, since only 21% of Americans were buckling up at this time. So here's a short ad of them that kind of began the widespread demand by Americans for car safety.
That's it. I'm history. End of the road.
You can't quit, Vince. No crash dummy takes out a utility pole like you do.
Larry, for years I've been proving how safety belts save lives, but nobody's listening.
Sure they are.
Yeah, that's why thousands die in car accidents every year. I feel like I'm banging my head against the wall.
Come on, Vince. Tomorrow's the big day. Two compacts. Head on.
High speed?
Could save a life.
No, I'll be there.
Yeah.
You could learn a lot from a dummy. Buckle your safety belt.
Back to the dummies though. There are three main sensors. First, the accelerometers, which are used to measure the acceleration in a particular direction, so that the data can then be used to determine the probability of an injury. The dummy has accelerometers all over it. For example, inside the dummy's head, there is an accelerometer that measures the acceleration in all three directions: forward to backward, up to down, and left to right. There are also accelerometers in the chest, pelvis, legs, feet, and other parts of the body. The graph on the left here shows the acceleration of the driver's head during a 35 miles per hour frontal crash. Notice that it is not a steady value, but rather fluctuates up and down during the crash. This reflects the way the head slows during the crash, with the highest values coming when the head strikes a hard object or the airbag. Secondly, inside the dummy are load sensors that measure the amount of force on different body parts during a crash. The graph in the middle here shows the force in newtons in the driver's femur during a 35 miles per hour frontal crash. The maximum load in the bone can be used to determine the probability of it breaking. Lastly, the motion sensors are used in the dummy's chest to measure how much the chest deflects during a crash. The graph on the right here shows the driver's chest deflection, which in this case deflected about 2 inches. To go into a little history of crash testing, in 1966, the US established the Department of Transportation in order to strengthen automobile safety, but even before that, the Institute of Highway Safety, IIHS, was established as a nonprofit organization funded by auto insurance companies in 1959. The National Transportation Safety Board was created in 1967 and later became known as the National Highway Traffic Safety Administration, NHTSA. In 1978, the NHTSA began its first crash testing with a 35 miles per hour frontal crash test. In 1984, a law requiring seatbelts in passenger cars was passed in the state of New York. And then in 1993, the 5-star safety ratings program was introduced by NHTSA to help make public the results of their crash test. In 1996, side impact testing began, and then in 1999, the US government required automakers to install driver and passenger airbags for frontal impact protection. And in 2001, rollover crash tests began. So as you can see, these tests are not that old. Like I just described in the history, there are two sources of crash test ratings in the US. There's the NHTSA and there's the IIHS. There are several differences between these two, the main one being that NHTSA is a federal government organization, while IIHS is a nonprofit group funded by insurance companies. NHTSA began their new car assessment program, NCAP, in 1978 with 3 tests: frontal, side, and rollover. Once they've conducted all 3 tests and averaged the numbers, an overall score is given on a 1 to 5 star scale. IIHS, which was founded much earlier, conducts its tests a little differently. For one, there's no star system. Instead, they rank vehicles in one of 4 ways. There's poor, marginal, acceptable, and good, with good being the highest possible rating. IIHS puts vehicles through 5 different crash tests. There's a small overlap front test, where 25% of the car's frontal width strikes a barrier at 40 miles per hour. Then there's a moderate overlap front test, where a larger portion of the car strikes the barrier. There's a side test, where an SUV-like barrier hits cars at 31 miles per hour. And then there's a roof strength test, where a metal plate is pushed against the car's roof to determine whether it would easily collapse in a rollover. And there's a head restraints and seats test, which measures forces on a driver's head and neck in a collision. IIHS has also recently started testing front crash prevention safety equipment, such as systems that avoid or alert drivers to an impending forward collision. The NHTSA crash tests include first the 35 miles per hour frontal impact test, where at 35 miles per hour, the car runs straight into a solid concrete barrier. This is equivalent to a car moving at 35 miles per hour, hitting another car of comparable weight also moving at 35 miles per hour. Second is the 35 miles per hour side impact test, where a 3,000-pound sled with a bumper runs into the side of the test vehicle. The sled's tires are angle. This test simulates a car that is crossing an intersection but being sideswiped by another car running a red light. Lastly, the dynamic rollover test uses an at-rest lab measurement called the static stability factor, SSF, that determines how top-heavy a vehicle is and whether it is vulnerable to tipping up on the road in a severe maneuver. Before the dummies are placed in the car for these 3 tests, researchers apply paint to them so that the paint marks in the car can indicate what part of the body hit what part of the vehicle. As you can see in the pictures on the bottom left, this information helps researchers develop improvements to prevent that type of injury in future crashes. Lastly, I'll finish with what is to come in the world of crash testing and safety in vehicles. It seems like airbags are sprouting from just about everywhere inside cars, and if they help keep your body from hitting hard objects during a collision, they're doing their job. But there's always room for improvement. Right now and in the future, the emphasis on safety equipment seems to be how to make them smarter. The most recent advancement being what's called the smart airbag, that can deploy with different speeds and pressures depending on the weight and seating position of the occupant, and also on the intensity of the crash. In the future, we'll hopefully see seatbelts that will also sense the weight and position of the occupants and adjust the tension and maximum force accordingly. On top of these, a new crash test dummy named Thor, which has been in development since the 1990s, is slated to hopefully replace the Hybrid 3. Thor represents the future of more lifelike crash testing, with a head and neck that is designed with muscular resistance to move like an actual human head. It will also contain 134 channels of data, 78 more than the Hybrid 3, so that it can decipher everything from the tension in the Achilles tendon during a crash to the force of a blow to the head in a front-end collision. All of this is happening as the NHTSA is also making a push in the US to make pedestrian crash tests mandatory, as well as rear seat occupant testing also mandatory for all new vehicles. Obviously, crash testing has come a long way in the last 10 to 20 years, as you can see on the bottom right, and it has a lot of improvements still to come. It may take wrecking a ton of cars and crash test dummies in the years to come, but the information gained from these tests means you can now survive a car accident with little or no injury, something that nobody ever imagined would happen. Here are the sources of my information. Thank you so much for listening, and I